Welcome back to Homework Help with Jen. Again, we're doing Chapter 1, and we're going to do in this video number 31 and number 33. And we're still looking at significant figures here. And if we look at the problem in the textbook, sorry about that, okay, 31 is asking us how many significant figures are in each of these problems. Okay, so I already have them written out here. So let's take a look at them. And what I'm going to do is I'm going to underline the digits that are significant, and we'll talk about the ones that are not. So the first one, 6.07 times 10 to the negative 15th. We have 3 digits here. 6, 0, and 7. Now a 0 is a 0 in the middle. So a captured 0 in the middle is always significant. So this one has 3 sig figs. Okay. Now this one is a little bit tricky. So we can see the 3 normal numbers here. And now we need to decide if any of these zeros are significant. So whenever we have a decimal point, all of the zeros at the end are significant, but preceding zeros are never significant. So in this one we have 1, 2, 3, and 4. Four significant figures, okay? And people never like this. They say, why not these? And the reason is because of scientific notation. If we were to put this in scientific notation, it would be 3.840 times 10 to the negative 3. Okay, so that one has 4 significant figures. Now, again, these are ending zeros, and it's after a decimal point. That's our trick here. So this one, I keep hitting the paper, has 1, 2, 3, 4. Okay, 4 significant figures for 17.00. 8 times 10 to the 8th has 1 significant figure. Okay, so let's come over here now. Okay, we have 463.8052. In this case, the 0 is captured, so it counts. We have 1, 2, 3, 4, 5, 6, 7. We have 7 significant figures in this one. Here we have 300. Now these zeros are at the end, but there is no decimal point, so they are not significant. So we only have 1 significant figure in this one. This 0 is captured, so it counts. 1, 2, 3. It's a middle 0. So we have 3 significant figures here. In this last one, it's 300, but it's written in a different way. Do you see the decimal point here? This decimal point means that these 2 zeros at the end are significant. 1, 2, 3. So it's 3 significant figures. Okay, now we're going to move right on to problem number 33, because it's really just a continuation of this problem. And what it does, if we look up here, is that it asks us to round these to a certain number of digits based on what our answer might be. Okay, and they also want us to write the answer in standard scientific notation. Okay, so if we look at this first one, it's 0.0003415.9. And the problem tells us that we can have 3 significant figures, okay? So preceding zeros never count. So we have right here, here, and here. Now if we look at our rounding rules, we have 5, 9. So since this is not exact, this is 5 or greater, so we round this up. So this means that that becomes 3, 4, 2. So we'd have 0.00034. But they want us to write this in standard scientific notation. So this becomes 3.42 times 10 to the negative 4, because we have 1, 2, 3, 4 spaces until we get after that 3. Okay, now let's go ahead and look at the next one. 1.03.351 times 10 to the 2. Okay, and they ask us to round this to 4 significant figures. 1, 2, 3, 4. This is 5 or greater, so we have to round that up. So this one becomes 103.4 times 10 to the 2. But this really is not in a standard scientific notation format, because we have 3 digits here before the decimal point. So we need to move the decimal point over and then increase these. So because we're going to go over this way by 2, that will end up becoming a 4. 1.034 times 10 to the 4th. Because what this 2 really means is that it's 10340. Okay, so let's come over here and we'll finish up number 33. We have 17.9915, and they tell us that we can have 5 digits. 1, 2, 3, 4, 5. So again, that 5 makes us round up, so we have 17.992. Now they want us to put this in scientific notation, so we'll have to move the decimal point over by 1, and so this becomes 1.7992 times 10 to the 1, because we've only moved that decimal point one place. Okay, next we have 3.365 times 10 to the 5th. So this is already in normal standard scientific notation. And they ask us to round this to 3 digits. Oh, look, they're all 5s. Isn't that funny? 1, 2, 3 digits. So this becomes 3.37. The 5 makes us round up, times 10 to the 5th. All right, so what I want to do is I want to do kind of one additional one here. Let's imagine that we have 3.362 times 10 to the 5th instead of a 5. Okay, just to review that the 2 means that we would round this one down, and just as that becomes 3.37, this one would become 3.36 times 10 to the 5th. Okay, so that we remember that we're not always rounding up.